The production of this program is made possible thanks to the support of the following and viewers like you. Will vanadium redox flow batteries address an issue that has been the Achilles heel of renewable energy production? That being the ability to store the power generated by wind and solar. The sector has challenges such as the inability of renewable energy sources to produce consistent on-demand power needed to supply an ever-fluctuating need. Matt Harper of Invinity, a leader in the battery storage system, says yes, and in doing so, he and his company will be filling a significant need in jurisdictions where there's been a huge increase in the amount of renewable power generated in those states, power that needs a home until it is required for use. Places like California, Australia, and Alberta. I invited Matt Harper to join me for a conversation that matters about harnessing, storing, discharging, and repeatedly recharging renewable energy to meet the electricity demands of the future. Welcome.
Glad to be here. Thanks for having me.
This has been a big part of the sticking point about how do we create reliability around the use of renewable energy sources, has it not?
Absolutely. Yeah. Over the last 5 years, what's been fascinating around the world is that wind and solar have become the lowest cost way of generating electricity in most jurisdictions. The problem being, of course, that as people start to use more and more of those sources because they are so inexpensive, the intermittency that they're sort of injecting into our grid system has become more and more of a challenge. Batteries have been around for a while that can do some of those kind of shifting and energy storage applications, but only recently are we starting to see an increase in demand and less of a demand and more of an absolute need to put some reinforcement behind those renewable generation sources so that they can become a bigger part of our electric grid.
Yeah, one of the, I guess, stumbling blocks or barriers has been the fact that it takes a long time to charge a battery. It has to be completely discharged before it can be recharged. How do you make all of that work on scale so that it can meet grid demands?
So it's one of the benefits that our battery technology has. You identified it up front. The vanadium flow batteries that we're making have an inherent flexibility to them that means that you don't need to do those full discharge cycles in order to keep the battery in top form. We can do partial discharge cycles. We can do very deep discharge cycles. We can respond to fluctuations in voltage and frequency on the grid within seconds, or we can turn around and take 8 hours of solar generation during the day and deploy it over 15 hours overnight. All of those things without introducing any further sort of degradation in the battery itself.
Okay, how does it work? Because I'm trying to envision this.
Yeah.
I'm used to seeing, okay, well, there's the battery, you put the charge in, it's all self-contained. And I get the fact that you're, putting a charge into the battery.
Yeah.
But vanadium redox flow batteries don't work that way at all, do
they?
they?
No, it's true. What we do is that we tear apart the two parts of the battery, the part that generates power and the part that stores energy. By separating those two things, we have the power generation in a thing that we call a cell stack, which is battery cells like you would see in a lot of other batteries. And then on the energy side, we have this liquid electrolyte with the vanadium liquid in it that stores the energy. Separating those two things from one another gives us a huge amount of control in terms of how we configure the battery, how we operate the battery, and ultimately gives it that level of flexibility. If you go to sort of the chemical level, what's really happening inside that battery is that with most battery technologies, every time you charge and discharge it, you're plating material onto an electrode and then tearing it off again when you discharge. With a flow battery like ours, the charge and discharge reaction takes place entirely in the liquid. That gives us a huge amount of flexibility in terms of how the battery can be operated. And it means that fundamentally, it's a very, very durable technology of the sort that you can deploy alongside, a wind farm or a solar farm, not for the 2 to 3 years that your lithium-ion battery in your cell phone might last, but for the 20 to 30 years that those assets are intended to be built for.
It has that kind of lifespan.
It does.
So what is it about the system that expands its lifespan so significantly?
So it's two things. First of all, it's that thing about the fact that the charge and discharge isn't involving the electrodes inside the system. It's all the liquid that's doing that hard work. And then inside that liquid, it's the vanadium ions themselves that are charging and discharging, holding and then releasing electrons. One of the amazing things about vanadium is that it exists in a very broad range of electrochemical states. So you can use it as both the negative side of your battery and the positive side of your battery. Together, that gives you the flow of current that is useful energy. And through those charge and discharge cycles over the course of years and decades, the vanadium itself always remains exactly the same species. It doesn't change, it doesn't degrade, it doesn't turn into gas and escape. It's always the same material. And therefore, the vanadium that's there on day one is there after year 25. And that's how we get that extreme durability.
So I got to get you to hang on for a second while we take a quick commercial break.
Okay.
We'll be right back. The production of this program is made possible thanks to the support of the following and viewers like you. So how do you get the power from, let's say, the wind farm or the solar farm to be powering this process, but also, while it's needed, still supplying to the grid?
Yep. Look, it's really a question of, well, for most of our customers, it's a question of what's most valuable at a particular time. You mentioned in your introduction, Australia and the US in particular. Those are jurisdictions where you're starting, in periods of the day where you have peak solar power generation, the price of electricity on the grid is going negative. People are being paid to take electricity away from the grid because there is so much solar power flowing onto it. What our customers are doing is they're looking at those market signals and making a decision whether their solar power is going to be flowing from their solar panels back onto the grid at a particular time, or whether they're going to take that and charge it into the battery so that it can be then discharged to the grid at a time when it's more valuable.
When demand starts to peak later in the day, when
Exactly.
people are going home and so on.
People come home, turn on their air conditioners, fire up the TV, turn the oven on, electricity prices go through the roof. Yeah, that's exactly it.
And so then they get a much greater return on
That's right.
the electricity that they're selling.
Absolutely. They get a much greater return. The other thing that we see in a lot of jurisdictions, and this is especially true in Australia, hasn't happened in Alberta yet, but I suspect we might get there, is that because solar power is so well proven and so low cost, people want to install more of it than the electric grid can absorb. And so what the regulators are saying now is, our customers are going to a regulator and saying, hey, I want to build 100 megawatts of solar. And they're saying, we'll give you 20. Because they simply can't absorb. They don't need it. So by including one of our batteries alongside those projects, you can upsize the project itself, which of course has knock-on economic benefits. So not only are you generating a lot more power to start off with, you're taking that power and delivering it to the grid when it's most valuable.
Wow. Okay. What's the scale of these batteries? Like, we're not talking about something that fits nicely on this tabletop.
No, I would have brought one with me had I had been able to do that. I mean, the downside of a vanadium flow battery is that it's somewhat more complex than the thing that you'd see in your cell phone or what have you. It's got pumps that circulate liquids. You've got cooling systems that sort of maintain the thermal state of the whole system. So what we do is we build a standardized battery module that is, say 6 feet wide, 6 feet high, and 3 feet deep. And then every one of those individual modules we can put on a particular site, depending on what the needs for that individual site are. So it's a very modular approach. And then we batch those together into what look like shipping containers.
A CCAN.
A CCAN, essentially, and then ship them off to site. And they live in that CCAN, they're installed in that CCAN, and that CCAN provides the structure for the thing throughout its operating life.
So it's all manufactured here, wired, ready to go.
That's right.
Basically plug it in once you get there.
Yeah, and we've got a global supply chain. We pull parts in from all over the world to through our facility here in East Vancouver. We put the batteries together. We manufacture all of our core technology in-house to maintain very close control and tight control over that intellectual property that's embodied in that stuff. And then we put the batteries together, we test them and make sure they're 100% functionally complete, and then we ship them directly to our customers.
Okay, I was reading that you basically came up with this system. You created it.
Yeah.
How did you go about doing that?
Well, look, the technology is not new. Vanadium flow batteries were invented in the late 1980s in Australia. There was a lot of pioneering development that happened through the 1990s and early 2000s in Australia and Japan. And then in 2005, there was a company here in Vancouver called VRB Power Systems that was doing some of the pioneering development of projects using vanadium flow batteries here in North America. I was part of that team. We licensed a lot of the original technology from Australia and Japan over to the company here. But what we found is that the technology was really good, but the product wasn't fit for purpose. Mm-hmm. We knew that the vanadium flow battery technology had some phenomenal capabilities, especially in terms of regulating output from renewable power, which back in those days, sort of 2008, 2009, was just starting to make an impact on the electric grid. But what we saw is that the technology hadn't been packaged in a way that was fit for purpose for example, wind projects. I'll use solar as an example.
Okay.
Solar projects were being deployed at the rate of, megawatts per week. You could put up a 20 megawatt solar plant in 3 or 4 weeks, hooked up to the grid and call it done. Vanadium flow batteries at the time were taking years to be built because they had to be built on site and turned into something that looked like almost a small chemical plant, and pipes and pumps and tanks and all this kind of stuff. So the innovative step that we brought to the market was to say, can we take this technology that we know well and package it in a way that it is a totally turnkey modular product? It comes off of a factory production line with great quality control, great cost control, delivered to our customers in a way where they deliver it off the back of a truck, hook a wire up to it, flip a switch, and they're ready to go.
This is our second break. We'll be back in a moment. The production of this program is made possible thanks to the support of the following and viewers like you. So, of course, one of the raw materials that you need is vanadium.
That's right. Yep.
Yeah. When we take a look at the battery market around electric vehicles and cell phones and everything, we keep hearing about lithium. And lithium is in incredible demand. We've seen the price go up 7,000%, I think it is, in the last couple of years, and rising.
Yep.
And getting new lithium supplies on the market is going to be challenging, especially here in North America.
Yep.
What's the market like for vanadium, and what's the accessibility to it?
So, first of all, vanadium is everywhere. It's one of the most common metallic elements in the Earth's crust. It's more common than copper, more common than nickel. The stuff is very, very widely available. Today, more than 90%, maybe even more than 95% of the world's vanadium goes into strengthening steel, especially products like rebar. And so because of that, it's typically some of the steel manufacturing countries that do a lot of that production. You see a lot of vanadium coming out of China simply because that's where so much of the world's steel is being manufactured today. With that said, there are sources of vanadium all over the world, but one of the new sources that we find most compelling is that there's also a tremendous amount of vanadium present in some of the waste products coming out of the petrochemical industry. If you know, one of the regulatory changes that happened over the last few years is that there's a new low sulfur standard for offshore marine fuels, and so all of the heavy fuels that are going into fueling the world's marine fleets now have to have sulfur removed from them. What comes with the sulfur? Vanadium. And so these catalytic processes.
Unintended consequence.
The unintended consequence is that there's a great source of supply for us starting to build up, which is phenomenal. So all around the world, these refineries that have these spent catalyst products starting to accumulate, where with this, the high sulfuric content, there's also anywhere from 8 to 60% vanadium in those materials. We think that's going to be a great source of supply for us from now into the future.
So you talk about the proliferation of solar generated power.
Yep.
And these facilities are not necessarily getting licensed to be able to deliver that power because the utilities got more than enough during the day. Yep. But we know that there are ever-fluctuating needs. What's the capacity of these vanadium flow batteries to be able to store power? Like, how much can you store, and in a particular unit?
I mean, by the numbers, every one of our 20-foot sea cans today holds about 230 kilowatt hours worth of energy. That's what your typical home might use in 10 or 15 days, something like that. What we're moving to a next generation of our product that will have 300 kilowatt hours in that same building block. And to give you an example, we're putting the finishing touches right now on a project in Alberta with a local renewables developer called Elemental Energy. And we will have 38 of those sea cans serving that 25 megawatt solar PV array that they're building at that site.
But one of the advantages of this system being remote communities that you don't necessarily want to serve as off of a grid, but you can now create power generation locally, store it locally, deliver it locally. Whereas there aren't systems right now that can meet that need.
Absolutely true, and it's one of the things that I'm most excited about in terms of sort of the future evolution of what these technologies will be able to do. There's a tremendous number of remote communities in British Columbia, in Canada in general, British Columbia definitely, all across the north that are all running essentially on diesel fuel. That diesel fuel has to be trucked in. It's very expensive. It is subject to supply chain disruptions, especially in the winter. And it's not an ideal source of providing the electricity that those remote communities need. By contrast, if you were to be able to take wind or solar power from those particular sites, store it in a battery like ours, probably have those generators still available for the 1 week a year where it's the middle of winter and yet the air is still, and so you don't have enough generation to keep things warm. But ultimately be delivering sort of 95% of your energy needs from those locally generated renewable sources. That would be revolutionary in terms of the cost of maintaining those communities and in terms of the sort of energy independence that those communities are able to enjoy.
Third and final break. We'll be right back. The production of this program is made possible thanks to the support of the following and viewers like you. I can imagine that there's an awful lot of communities and countries that have an abundance of sun, but do not have infrastructure in place right now, where they are relying on diesel generation that is unreliable, incredibly expensive, that you can wind up replacing that and giving them the one thing that they haven't had is the ability to store this power and use it as required.
No, that's absolutely true. I mean, one of the things that we look at a lot as an example of how we think, certain parts of the world are going to evolve in this way is, you look at how the cell phone infrastructure rolled out across Africa, in sort of the years between 2000 and 2010. It basically rolled out far faster than regular phone services ever did, or even faster than the electric grid could be deployed, because it's mobile. You pick it up, you move around, you put up a cell tower somewhere, and all of a sudden you can serve this huge area from a single point of infrastructure, rather than having infrastructure that stretches out across the continent. In effect, we think that this distributed generation model, where you have, whether it's a mining camp in northern BC or a remote town in Uganda, that has a need for power, instead of bringing it in, instead of stringing up electricity lines that are subject to, who knows what kind of damage. Self-generate it, do it locally, right? Be able to produce it yourself, be able to store it yourself for when you need it most. And then you've got that degree of energy autonomy, which is really powerful.
So I note that you're not just here in Vancouver; that you're also elsewhere. Already, you're gaining a considerable amount of momentum. Where else are you building units?
So so as a company, we've got two main operating bases. One is here in Vancouver. One is in a town called Bathgate, which is just outside of Edinburgh in Scotland. Those are our two main facilities for battery production and for doing all of that sort of core technology manufacturing that I talked about earlier. And then ultimately, those are also the sites from which we ship to project sites all around the world. Most of our business today is in the UK, North America, and Australia, simply because those are three jurisdictions that have not only a pretty significant need for storage as it stands, but also have market structures that support the implementation of those projects. We can actually put these batteries on the grid and make pretty good revenue, or at least our customers can, in those three jurisdictions. So that's most of where we look. We have been opportunistically starting to explore other jurisdictions as well, primarily based on the strength of the partnerships that we're able to make elsewhere. I'm personally not going to go and spin up a business development office in Taipei, for example, but yet we've had some great partnerships in Taiwan that we've been building over time, to be able to deliver the benefits of these products into their market.
Well, as it starts to take hold and your reputation grows, I think your biggest challenge is going to be how are you going to scale up to meet that demand?
Absolutely. I mean, our biggest corporate partnership is I mentioned that we're developing a next generation product. We're doing that in partnership with the team at Siemens Gamesa Renewable Energy, they've been great partners to us. They focus primarily on the wind energy sector, and regulating the output from a wind turbine is an incredibly punishing duty cycle. Not only do you have to regulate for the individual gusts, but then you have to be able to take that energy and push it into the times of day when the air is still. Right? It's a very, very diverse duty cycle. Their view is that if we're able to hit our targets, our milestones for this particular product and get it to market in the way that we intend, that we will be able to sell as much of this stuff as we can build, just because there's such a huge need for it.
Well, because you complete the circle in that production.
Yep.
You're not just power generation, but your power generation, storage, and then the ability to deliver on demand, which has always been the concern about renewable power sources.
That's exactly it.
I wish you great success, and thanks for coming in and giving us an insight into your world.
Always happy to do so. Thanks very much.